My name is Farris. I'm a data analyst at Megaputer. So machine learning in a hand-wavy, kind of almost sloppy definition is basically understanding that teaching or instructing a computer how to do something can be incredibly complicated and time-consuming or impossible. So what's easier to do, and probably better to do, is to provide examples of how to do something and then let it learn from those examples. And then it will magically give you the solution. Now, philosophically, it's not really learning anything. Our machines aren't capable of actually learning, so it's kind of a careless name. Really what's going on is we are using data to fill in holes in our solutions. We have an existing solution that's missing some information. We need to calibrate some numbers here and there, and so we're using data to do that. And so we're using math, statistics, and algorithms to kind of fill in all those blanks. So what might help you understand it is thinking of a graph with a bunch of dots on it. You probably remember in high school, you can draw a curve through that graph to kind of guess where that line should go. And so you kind of make a rough estimate of what's really going on. Machine learning is just you're giving it the dots and then it's using math to create the line itself. It's not magical or sentient, it's just using math and statistics to do something pretty complicated. And so we could, as a human, do it ourselves, but we can automate it, so why not automate it? Machine learning is a subset of artificial intelligence. Artificial intelligence is a very broad category. Basically, it's the task of trying to simulate intelligence or actually create intelligence, whatever we kind of philosophically mean by that. There are many ways to do that. Machine learning is just a subset of that field. It's a pretty broad topic, and so when we talk about a lot of things, they can be used interchangeably because really they're so heavily involved in one another. There are a lot of reasons for that, so I'll just kind of narrow it down and give two. One is more optimistic, and the other is a little bit more cynical. These aren't competing arguments, they're just kind of both pieces of a puzzle. So the optimistic reason is that machine learning simply is powerful. It's been proven to be powerful. Not only is it successful and able to kind of create these complicated models and reproduce intelligence in a way, or intelligently solve problems in a way, it's relatively easy to use. You don't need to hire a massive team of engineers to build a complicated system. All you really need is an understanding of math and statistics and a lot of data. And luckily we're living in an age where data is plentiful. And so if you have this data and you don't know what to do with it, machine learning is something you can throw at it to see what can we do with this. It's kind of automated. Now the cynical portion is that because it's so easy to use, you don't need to have that intimate understanding of it. For a lot of people, it's kind of mysterious and they don't understand the nuances of under the hood, how it actually works. And so that can lead people to think it's some sort of magic wand they can just point anywhere and they're going to get magical results from it. It's not. It's not the ultimate solution to everything. It's simply a powerful tool that you need to know how to use, when to use it, because it does have limitations. So those two things are kind of, the power of it and this mystery of it have really amplified people's interest in it. AI is used in a lot of different areas that I work with now. Machine learning that we were just talking about, I use it mostly for making predictions. Machine learning is good for learning how to do certain things and replicate certain things in the future. So if you have a good set of data that shows what you should be looking for in the future, you can train with that data and create a model to be able to predict new things as they come up. So I use that a lot in my current work, but also maybe that's something that I use personally, but I take advantage of because someone else did the work with AI, is the value AI has added to natural language processing and text analysis. A lot of our tools for text analysis come from artificial intelligence. So being able to automatically detect whether a word is a noun or a verb, or how words are related to one another in a sentence, all of that I take advantage of my daily work is built upon artificial intelligence. And so all the small things I can able to do without an effort is built on that bedrock. Computer vision. Having a computer take an image and being able to know what's in that image, something that we do without effort, it's actually quite complicated. And so artificial intelligence, machine learning in this computer imaging has been really successful. So a very simple level, you can think of it as you give me a road sign, and I will tell you what that road sign is. As a human, I can do that really easily, but we've also trained machines to be able to do that too. Now extend that to have a live cam of a road as you're driving along the road, being able to take in all that live feed, process everything that's going on, where the road is, where the median is, where other cars are, where the signs are, all that information needs to be processed really rapidly for self-driving cars. So we can build upon this in more complicated stages, and so you can see how machine learning is really important there. Other areas kind of going in a different direction. For hospitals and doctors, we've built machine learning models to help diagnose diseases like cancer. So we take information, doctors, they've been doing this for decades. We can see what they have done, use that data to train a model to do it. That model can assist a doctor in their diagnosis. It's kind of in legal limbo right now because we've had several models outperform the doctors, and so the question is, should we rely on those models or should we let a human make the decision? But the point is, we've had great success in this medical area. So really the answer is everywhere. Machine learning has been able to do a lot of things in pretty much every single field. It just depends on how much time you have to sit and listen about it. The primary thing that one needs to understand when they start using machine learning is data. Data is required for machine learning, just the actual data is needed. And along with that, you need to kind of have an understanding of what your data is. You need to understand where it came from. Do you have enough? Is there some sort of bias introduced into it? How you collected it or how you're sampling it, etc. So that understanding will affect how you go about creating your models and how you test them and how you appreciate if they're working or not. More intricately is your variable selection, how you're choosing what pieces of your data you want to actually use to make your predictions and what you're giving to your machine learning model to actually learn from. So a nice understanding of your data itself and its role in the machine learning process will go a long way for someone beginning to learn about machine learning. So we have to break this down kind of on two different levels. The first is what we really mean by success in this idea. So are we saying is something that's mimicking a human behavior and it's really intelligent? Is that what we're calling success? Or do you want to raise the bar and say it has to be hyper intelligent, has to be sentient almost? Or actually sentient, in a way. And then we have to break it down on what time frame we're talking about. So considering a hyper-intelligent a piece of AI, say something like then communicate with us in a language that it can speak to us, we can talk to it, it responds, we can have a nice conversation, and it's no different than a human. That sort of singular thing probably will be possible within my lifetime. Something that can talk and drive a car and can reason and make deductions and can make, to solve math problems, can solve logical problems, can learn in a way a human learns, because we talked about machine learning, but machine learning isn't really learning, it's just solving in math problems kind of automatically. Learning as a human infant would, by taking in the world and then wiring itself to understand it. That sort of complex thing, probably not in my lifetime, and then you add on actual true sentience and understanding of the world the way a human mind does, probably not my lifetime. The human brain is the most complicated piece of machinery in the universe, and mimicking it, let alone actually kind of reproducing it, is an extraordinary, complicated, and difficult task. I don't see it being possible. That being said, decades ago we couldn't imagine the things we have today. Technology is moving at a rapid pace, so I might be wrong. We can't predict the future that well. So thank you for watching. I've hoped this has been interesting. Maybe you learned something. If you're more interested in artificial intelligence, machine learning, please visit our website for more information.